Hello everyone, in this video let's discuss about the link state routing algorithm problem in the computer networks. If you are new to our channel, please subscribe for more engineering related topics, and the whole playlist link of the computer networks is given in the description. You can access it and you can find out how easily you can solve all the problems there. Now, how easily we can solve the link state routing problem is, there will be given with a graph. So if you consider it as a data structure, we will call it as a graph. This is a routing diagram. So all the router A, E, B, C, E, all these will be called as the routers. Okay. Now what we should do is shortest path from one router to all the router. If I consider A as the source router, I must be finding the shortest path from A to all other routers. So what we should do is, the source router from which we are finding the shortest path will send the hello packet to all the routers. So when it sends the hello packet to all the routers in the routing connection, there will be a link formed between the routers. So how means, if you see the diagram, let's draw the routing table for all of them. This is for the A, this is for B router, C router, D router, E router and F router. Now from A, where is direct connection? So wherever direct connection is there, you must consider it. From A to B, A to E. From A to B and A to E. So from A to B, what is the path cost? 4. From A to E, path cost is 5. Now from B you can go to A. From B you can go to A. From B you can go to C. From B you can go to F. So from B to A it is 4. B to C it is 2. B to F it is 6. Now from C to B you can go. From C to E, C to D. C to B is 2. C to E is 1. C to E is 1. Next, C to D. C to D is 3. From D you can go only to C and F. C and F. What is the cost? From D to C it is 3, and from D to F it is 7. Now from E you can go to A, you can go to C and you can go to F. What are their costs? From E to A it is 5, and E to C it is 1, and E to F it is 8. Now the last one, that is for F. From F you can go to E, from F you can go to B, from F you can go to D. From F to E is 8, from F to B is 6, from F to D is 7. Now we completed all the routing tables. So what this routing table does is, they will be sharing the information with all other. Therefore each router will be having the information of all the router. If you consider F router will be having all the routing table information, that is of A, B, C, D. All the information will be at the F, like that. All the routers will be having all the other routers or the neighboring routers information. Now to proceed with the problem, we will be using the Dijkstra algorithm. Dijkstra algorithm. So it is mostly like the data structures problem only. Now what we will do is, we will be finding the shortest path. Let's consider a source node. If I consider A as the source node, from A I must find all the possible shortest path from A to all other routers. From A to B also we must find the shortest path. From A to D also we must find the shortest path. Now I will consider A as the source. So next, what are the left out routers? B, C, D, E and F. Now let's find the shortest path. So if you see the routing table of A, it is directly connected to B and E. So B and E, what are their value? 4 and 5. From A to B it is 4 and from A to E it is 5. So other value we don't know, so let's put infinity, because we don't know the value from A to C and A to F. Now what we will do, which is the smallest number in whole of them? So 4 is there, infinity is there, 5 is there. So which is the smallest number? The smallest number is 4. So what I will do is, I will take 4 downside with the reference. That is, A is already selected for the shortest path. From A you will be going to B. From A you will be going to B. Now what will be the shortest path from A to B? It will be 4 only. From A to E it will be 5 only. From A to B, what is the cost? That is 4. Plus from B you must go to C. From B you must go to C. Its cost is 2. So total it will be 6. Now from A to B we already know it is 4. Plus from B to D. From B to D you don't know the value. From B to D you don't have direct connection, so you don't know the value. You will be putting infinity there. Next, A to B it is 4 and B to F. So B to F is 6. So 4 plus 6 will be 10. So you just write 10 here. Now B is already considered, so round up that one only. B is already considered. Now again consider in this one which is the smallest. So 4 is already considered, you leave it. Now which is the smallest among these 4? Which is the smallest among these 4? So 5 is the smallest one. So 5 is the smallest one, means which will be selected, that is which router will be selected? E router will be selected. Therefore A, B, E are selected. Now from A, B, E to B, which is the shortest path? 4 will be the shortest path. Here 5 will be the shortest path. Now from A, B and C, using A, B, or from A, B or A, B, E, you must go to C. The shortest path is 4 plus 2 is 6 and other possible path is 5 plus 1. 5 you will come to E and from E you will go to C. It will be 6 only, 6 or 6. So equal means you can write 6 directly. Now from A, B, E you must go to D. From A, B you can go to D, or from A, E you can go to D. But there is no direct connection for B also, for E also. We will be writing infinity only. Now using A, B, E you must go to F. So from A, B it is 4 plus from B to F it is 6. See, from A to B it is 4, from B to F it is 6. So it will be 10. Or another possible path is from A to E it is 5 plus from E to F it is 8. So it will be 13. So which is the smallest? The smallest is 10 only. So I will write 10. So all the possible path you must see, but you must write the shortest, because we are finding the shortest path from one router to all router. Now 4 was already selected, 5 was already selected. Among 6, infinity and 10, which is the smallest? The smallest will be the 6. So now which router is selected? C router is selected. A, B, E, C. Now 4 will be as same, because whichever you round up it will be same in the next step also. 6 will be same, 5 will be same. Now let's find for D. A, B, E, C, you must go to D. From A to B it is 4. From A to B it is 4. B to C, you can go to C, no? So B to C it is 2 plus C to D it is 3. So it will be 3 plus 2 is 5, 5 plus 2 is 9. Other possible path is from A to you can come from A to E, that is 5, plus from E to C, that is 1, plus from C to D, that is 3. So it will be 5 plus 3 is 8, 8 plus 1 is 9. So 9 or 9, you can directly write 9. Now for this one, from A, B, E, C to F, A, B or A, E you can use. you must go to F. So the shortest is 10 only, because 5 plus 8 is 13 or 4 plus 6 is 10. So 10 is the shortest. Now among 9 and 10, which is the shortest one? That is the smallest number. 9 is the smallest number. So which router is selected? D router is selected. A, B, E, C, D. Now whichever the value you rounded, you just write them only. 4, 6, 9, 5. So you must find the shortest for only F. So using A, B, E, C, D, you must go to F. So the possible shortest path is this one only. 4 plus 6 is 10, and this one is 5 plus 8 is 13. So the possible shortest path is using from A to B and B to F with the shortest cost, that is 10. Now this will be rounded, that is F is rounded, you will be taking A, B, E, C, D, F. So this is the possible shortest path to cover. So this is the possible shortest path to cover all the routers with the shortest or the lowest cost. Now I said from one source router you must find the shortest distance for all of them. Let's find them. From A to B, C, D, E and F. From A to B, so which is the smallest? A to B. When B was selected, it was 4. From A to C, when C was selected, C was selected because of 6. So 6 you write. Next D. So because of whom D was selected? 9. Next E. E was selected because of 5. F was selected because of 10. So these are the shortest distance from source router A to all other router. Hope you understand the concept of the link state routing algorithm, and if you understood, please comment below, and please like and subscribe for more engineering related topic, and support us for doing more this kind of videos. Thank you.